just a word before we do. The uh, I think that the audience will really be looking for the discussion between the two of you. So I will try to have as little footprint as possible. I'll ask questions from the list if um, to help keep things moving along. But as much as the two of you feel like just going back and forth between yourselves on the questions you find most interesting, I think the audience will probably find that the most interesting as well. So,
Is this mostly our audience? Is it mostly academic students or people in academia, or who else might we have on the
I
call?
I believe it will be mostly students is the largest share,
Okay.
although
We we, we, we
some.
we have both. We have both. We have young engineers from the industry. We have also students from United States and from all over the world.
Okay, great.
Well, then I think we're going live, and I'm Ben Ebenhack. I will be moderating the session. And as I just said to our two panelists, I will try to have as small a footprint as possible because you're here to hear their wisdom, not to hear me asking questions any more than necessary. So I'll ask each of you to introduce yourselves in the way you wish. Mr. Horn, would you go first?
Yes, sir. I'm Aaron Horn. I'm Vice President of Infrastructure, Water Infrastructure for Select Water Solutions. I have an engineering degree from the United States Military Academy at West Point and um, graduate and advanced degrees in conflict management and organizational leadership. And I've been in the industry for about 18 years and been in water for about 16.
And Dr. Malmali?
Yeah, good afternoon, everyone. Mahdi Malmali, an associate professor of chemical engineering at Texas Tech University. And I finished my PhD in 2014, then did a short postdoc and started my independent career in 2018. So now almost 7 years doing this. And since I was doing a PhD, I was working on produced water and water treatment application stuff, especially using membranes. My lab particularly is interested in using membranes filtration systems for desalination. And we are mostly interested in thermal membranes and essentially trying to deal with concentrated brine streams. Recently, a lot of kind of interest in resource recovery, critical minerals that exists in actually produced water. And we are working on some design of materials kind of that can capture and separate those critical minerals from highly concentrated brine streams. And it's a pleasure to be here.
Great, great. Well, to start us off, what would each of you say produced water management means, especially in the context of the Permian Basin?
Aaron, do you want me to go first?
Yes, sir. Produced water management in the Permian Basin. So there, as I'm sure most of our audience knows, the Permian Basin is the most active basin in the United States, maybe in the world, I'm not sure, but it's certainly in the United States. It's where all the activity is. And there are several barrels of water produced with every barrel of oil. So we are a water management industry, and our byproduct is oil. So the water management boils down to produced water management, especially, of course, the traditional um, means of managing it is to gather it and dispose of it down disposal wells. And over the past Certainly, it's gained speed over the past 5 years, but for 15 years, there's been a movement to use that water for other purposes. And one of those purposes is to supply hydraulic fracturing operations with produced water, with treated produced water. And the other, which Dr. Malmali would, I'm sure, have a lot to say about, is the push towards treating produced water with membranes or thermal processes and use that water for a beneficial reuse outside of the industry. So when we say in the industry, when we say recycle, generally speaking, we're talking about using produced water for fracs, using produced water for some other operation within the oil and gas industry. And the lion's share of that is going downhole on hydraulic fracturing operations. When we talk about transforming water into a product that can be used outside of industry or for agricultural purposes, we normally say beneficial reuse. And so produced water to me is in the Permian Basin is gathering produced water, trying our hardest not to send it down a disposal well and find other ways of using it, because it's becoming a very valuable, precious resource, given that the operations are in the desert and we don't want to use fresh water if we don't have to.
Yeah, I totally agree with what Aaron said. Sometimes I make a joke to people external to oil and gas produce water or operations, is that oil companies, they think they're making oil, but they're making more water than oil. So in Permian, at least per barrel of oil, you're producing 6 to 9 barrels of produced water. So it's a significant amount of water being produced. And honestly, I'm amazed how companies upstream, midstream, they deal with this, because it's enormous volumes of water being produced, 27 million barrels of water per day. So even if you think about it, if you drive around Midland area, which I usually do a lot, sometimes we go to Select, we work with Select on one of the external reuse applications that we have there. It's nothing there. It's just essentially in the middle of nowhere. There are some wells, some tanks, and again, thinking of how 26 million barrels of water is being collected and redistributed. Unfortunately, most of it is being discharged into deep wells. Still, it's amazing. I think what really makes it super difficult is that how to balance the needs with the supplies. There was a very interesting figure from one of these consulting companies that it used to be live online available, but they took it away. That essentially it was showing how much water is produced in each well with respect to time. First 5 days, a couple of million gallons of water every day, and then in day 4 or 5, it goes to almost 1,000. So essentially, how to supply all that water at the beginning, and then how to shift it down with some produced water coming out, but at significantly lower volumes. Again, it's amazing. It's a very, very, very difficult task. That's why I think in the last 10 years, there has been the enormous, essentially, rate of midstream companies to put piping systems, to come up with some simple treatment applications that they can use it for internal reuse. Like 10 years ago, they were thinking, or 15 years ago, they were thinking that, no, you cannot use this water again. But then they realized by changing the characteristics of the fluid, they can recycle 100% of that water. For sure they can, but the major problem is that there is an imbalance between the demand and the supply in every well. So essentially, at the end of the day, there is a more positive discharge because you're making more water than you need at that point at that specific time. Maybe next week you need more, then you have to use to get that source of water from somewhere else. So again, I think it's in academia, we're always trying to look for grand challenges to solve, and that's how we try to show the impact of our work. And I think produced water definitely, for Texas particularly, is now a grand challenge. And but it's very one of those grand challenges that is pretty tough. It needs different aspects of engineering science. and policymakers, everyone to work together to get it kind of repurposed for internal or external beneficial use.
Seems that you're both uh, highlighting that part of what makes it such a critical challenge in the Permian is the sheer magnitude of the water and the water oil ratio. Um, could you each comment on how your organization or your research are currently approaching this solutions for the water problem in the basin?
So Select has a unique approach to water management in the Permian Basin, especially, and certainly a technique or a approach that we want to apply across all basins. Our approach is to recycle first. So we're building out our water infrastructure, which involves or includes pipelines and treated produced water ponds, very large ponds that hold 1 million barrels, and treatment systems. And we're building that out with a strategy, with a plan to recycle first rather than to send down disposal wells. Now, we're always going to need disposal wells. So it's not that one is better than the other. The industry needs both approaches. But Select's approach is we're going to we continue to make enter into agreements with our customers, and those agreements usually entail both a gathering component. So we will make a deal with our customers to bring water into our infrastructure, our network, which for Select, we have a few hundred miles of pipeline in New Mexico. We have 18 million barrels of storage, and we have, as far as treatment capacity goes, we have about 1.2 million barrels per day of treatment capacity. So we draw water from our customers into this system, and then we store it in treated produced water ponds, and then back out to those same customers, and also on the spot market to customers who don't sign long-term agreements with us. We send the water back out to them for hydraulic fracturing operations. And it's a different approach. Our competitors are primarily, and I think completely, saltwater disposal or underground injection first. So their first option and their primary option is to gather that water and put it down a disposal well. And again, that's important. Again, we're not saying both approaches are needed, but Select wanted to enter into this market, transform ourselves from a water services company to a water infrastructure company, which we have done at a very rapid pace in Texas and in New Mexico. So we are managing about 400,000 to 500,000 barrels a day just in New Mexico, which is the area that I'm in charge of. So a lot of my comments are going to be weighted towards New Mexico versus Texas. But we do about equal to that in Texas. And so we're managing up to 1 million barrels a day. That's not capacity. That's water that's coming in and going out every single day, coming from customers, coming from producing wells, and then we send it back out to those customers and to others for fracs. So that's our approach, and we've been successful with it so far. We've had great success with it. The key to all of that is to be consistent and dependable in the takeaway. And you have to be consistent with the providing of the water as well for the fracs. But we at our water recycling facilities have to have the same uptime as a disposal facility would have. And you're talking high 90%, 95 to 99% uptime on disposal wells. So the key to our strategy has been to connect as many customers as we can and build our entire strategy around dependability. So we have redundancy. We have as much storage as possible. We connect all of our storage with pipelines so that we can move water from here to there to create space or to push our inventory into a geography where the most fracs are happening. So that's been our approach. It's going really well. We're excited about it.
Yeah, obviously, at least we are in the university, we are more interested in doing things that are not yet out there, but trying to solve some problems that are coming up maybe in 5, 10 years, and trying to develop the science and knowledge and technology around those problems. So, as Aaron said, at the end of the day, disposal is going to be a part of it, and uh, the volumes that are being disposed still pretty significant, and but the capacity for disposal is shrinking, especially again, scientifically, they are showing that there are some correlations with the well bore pressures, and the seismic activities in Texas, and now it's becoming a significant concern. New Mexico, I think, a couple of years ago, and Oklahoma, they put a lot of stricter regulations on disposal. And since Texas is a free state, now a lot of water is being pumped to Texas for disposal. But now for Texas is being also a concern. So all in all, there should be, as I said, a combination of technologies, redistribution, piping, refracking, but at the same time, desalinating produced water, because, Texas in 30, 40 years is going to run out of water. There is a report by a group, Texas Water Board, I think, that they are saying by 2070, the Texas, the major portion of Texas is going to be completely out of water. And very interestingly, if we can desalinate, we can collect and get this water together, desalinate like a portion of it, then we can kind of repurpose a lot of that water, particularly for agriculture applications. There are a lot of plants, a lot of agriculture applications that they can't survive with essentially a little bit higher salinity of water. And then if we can do some desalination and get hopefully environmentally benign and safe water streams that they could be used for agriculture purpose, that's one of the applications. Or for aquifer kind of refilling, we can put this water back into the water cycle, or we can surface discharge. So there are those opportunities there. Obviously, one of the probably key kind of subjects that Aaron and I probably going to talk about it is essentially how the permits are going to be allowing this to happen or not to happen, and whether essentially everybody's going to work together to get enough data and information out there to this regulatory agencies to let them provide the permits to do this job or not. Again, it was a long introduction, but for me, I'm very interested in kind of desalination. And at the end, even if you do desalination, you end up by having some brine streams. My experience is that, especially in Texas, going to zero liquid discharge, which means completely evaporate or take the water out and produce some solid, is not very favorable, because the cost of disposing salts is crazy expensive, a couple of $100, like $600 or $700 per ton for disposal. So that's why near zero liquid discharge applications are very interesting, in my opinion. And also how to get very concentrated brine and chemically transform it to something that you can use it on site for internal reuse. Like, you can get 250, 300,000 ppm salt or brine and try to convert it to acid and base using some electrochemical processes. And if you don't know how much salt is that, it's just you put 800 milliliters of water in a beaker and then put around 300 grams of salt in it. And then put your hand in it and take it off. Within a second, you will see crystals of salt are showing up on your hand. So it's pretty concentrated, but we are working on a technology to convert that to acid, like hydrogen chloride or sulfuric acid, and also to base using a technology called bipolar electrodialysis. And it's a very interesting technique. One major challenge is that the concentrations of the products that you get is relatively low. You get to two normal acid or base concentrations. What we are trying to do now is trying to play with that technology to get it to really concentrated acid and kind of base. So that way you can use it internally. They can use it for well acidification for the acid, and also for the base, they can use it for water treatment. Sodium hydroxide has a lot of use in a lot of pretreatments that they do on the water. So that's one of the technologies. The other technology that we are working for this desalination part of it is membrane distillation. It's one of the many types of thermal desalination technologies. In my opinion, most of the thermal desalination technologies are the same. The question is how we can deploy them to this environment, at what size, because economy of scale is pretty important. How much you can recover the heat is important to increase your efficiency. And also how you can reduce the environmental impact of your thermal evaporation. Like mechanical vapor compression is very easy, but how to make sure it's environmentally safe, it's a big problem. But remember, in distillation, we have had a lot of success. We have a pilot plant running on membrane distillation, funded by Department of Energy, a couple of projects. So we are very interested in designing those membranes. But something else that I do in my lab is that, like a couple of years ago, I was doing a lot of work on desalination, and we realized that no matter what, the desalination is at least twice more expensive than purchasing a new barrel of water and then discharging a barrel of water. At that time, with 60 cents, you could pay 40 cents to buy a barrel of water and pay 20 cents to discharge water, while desalination was around 1.2, $1.5 per barrel. And since then, I have been always thinking of how we can offset the cost. And because of that, we started being interested in critical minerals recovery before this hype was even becoming this important and critical materials and resource recovery and valorizing produced water. It was like in 2019 and 20. If we started looking at lithium extraction from produced water, that's something that we have now, some technologies that membrane technologies that they can extract lithium. And now we're also looking at some electro precipitation technologies that we can extract some of the rare earths or other critical minerals that we can find in produced water. Yeah, a lot of materials, new materials, membranes, filtrations. So, and it's getting more and more exciting.
I wanted to piggyback on one comment that Dr. Malmali said in terms of scales and size. So I believe, and this is just my belief, based on a career in water treatment, which doesn't mean I'm right, but I believe that desalination is certainly going to be a part of the solution, and we're just at the very early innings of figuring out the commercial and the technical aspects of that. Technically, coming from an old water hand, we can remove anything from water. There's nothing in water that you can't remove. It's just a matter of cost. Right? It's a matter, is it commercially viable? And I believe that the path to commercial viability is going to be centralized treatment at a scale that the industry, at least in the, quote unquote, unconventional plays that are basically now conventional, in the shale plays and the tight sand plays, all the plays that are producing the most oil in the world right now. In these plays, the treatment should be at a scale that we are not used to seeing. I think the pipeline networks that are gathering this water and managing this water continue to continue to grow. The networks continue to grow. Companies like mine continue to invest capital in them. And you've got this, at first it might have looked like a spider web from the top, but now it's 5 spider webs overlaid on each other. And we're all our company and all of our competitors, which we kind of think of as frenemies because we cooperate a lot, but we're still in competition with each other. We are connecting anytime we overlap each other's pipelines, we connect to one another as soon as it makes commercial sense to do so. So now you have these networks that are now being connected to one another, and all of a sudden, you can move water, you can move 100,000 barrels a day, 60 miles from one end of a play to another. And in combining these networks and expanding these networks across companies like Select and other companies that do what we do, you will be able to consolidate at some point in the future, not too distant future, consolidate easily 1 million barrels a day in one spot. And I think that's the key, because when you have 1 million barrels a day, you start to, your fixed kind of personnel costs for operating a plant like that just become de minimis. And now it's a matter of putting that plant where pipelines intersect to bring you the volume, and there's also a energy source, a power source there that is dependable and ideally cheap. And then having it near, or even building a railway spur that goes by the facility to deliver in mass and take waste away in mass. And even if I think the path is going to be concentrating all of the dissolved ions, all of the dissolved solids into that concentrated brine that Dr. Malmali was talking about. You're still going to have some components of that you have to precipitate out during the treatment process. So you're going to have a lot of waste. And I believe that I think that is going to be the answer. You're going to have a treatment plant that looks like a refinery, and it's going to be moving 1 million, 2 million, 5 million barrels a day through it. And at that point, you reach the economies of scale that make it competitive with other alternatives.
Yeah, totally agree. I didn't know that you guys work together for the pipelines. I was always thinking that once I was driving near Midland, and I was lucky to have somebody who was in the oil and gas business for more than 40 years. He was the vice president of Pioneer. And the good thing is he was explaining to me every single sign, every single truck on the road, what they are doing. And based on the science he showed me, essentially that area is packed with pipelines. So now thinking about even more pipelines are added for handling produced water. It's pretty interesting that you guys are working together and you share pipelines with different companies. That's pretty interesting. So you work together and you share the pipeline, right?
We do. I'll tell you, Select has a point of contact at every single one of our competitors, and we talk to them at least monthly, if not weekly, to work together. And of course, we're all motivated by profit, and we all have to make our profit, and we all understand that. And there are firewalls. We're not going to share with them our operating costs, things like that. But there is a level of disclosure and trust that is starting to develop in the water management space that hasn't been present before. And that's creating the foundation for some really strong partnerships that are bringing the industry water management costs down. And we all understand, we being Select and our competitors, if we bring the industry water management expense, the LOE down, they're going to drill more, and that's good for us. So a high tide floats all boats.
So what is stopping us from having a plant like a 1 million barrel per day desalination plant near Texas and New Mexico border?
Oh man, it's a good question. I don't think we're too far away from it. It's not months away, but it's also not a decade away. I do think that there are a lot of entrepreneurs and a lot of people with capital and the means and the experience to do so that are looking into that. I think that's the way to go. It's not something that Select is doing at that scale right now, but we are, as you said, Dr. Malmali, we're working on R&D right now. We're trying to figure out what's the right technology to deploy, and then we'll build a business around it. As far as what's preventing us, I think it's figuring out how to make it all commercial, how to make it all make sense. So as you said, the cost to desalinate is far more than the cost to just treat to reuse in the industry. So to treat water and reuse it for a frac, depending on various things, you might be between 10 and 30 cents a barrel. And I'm not up on the latest OpEx from pilots for desal, but you're probably looking at not an order of magnitude higher, but 3x, 4x higher than that. So we have to figure out a way to have a good use of the fresh water that comes out of that, the desalinated water that comes out of that, something that makes it a commodity and not a waste, because we know it's certainly not a waste. but there are regulatory hurdles to make those things happen. And then we have to figure out the precious minerals part of it. During that process, and it's kind of synergistic, you will concentrate those precious minerals into a lower stream of a smaller volume of water. And a lot of the technologies to extract minerals like lithium, they need a certain concentration to be commercial. And now after concentrating it, it is commercially viable to extract lithium, and there's some other precious minerals in the water that can be extracted. So I don't think I mean, we're refining the technologies, but I think it's figuring out that commercial piece. And it takes a while. It's going to be a huge shift for the industry, and it just takes. There's a lot of smart people that are working on this, and I don't think we're 10 years away. I think we're probably 3 to 5 years away from having something at scale. But that's just my opinion.
Yeah, I think my opinion is that because I have been working with a lot of companies who are involved in this, consulting to some of these companies, building large plants at this point. And I think the major factor that is stopping it, in my opinion, is uncertainty, and also the cheap cost of water at this point. At this point, the water is so cheap that uh, it's not really a big problem to just get more water coming in, even fresh water, and essentially do the fracking job. But essentially, who knows what is the cost of that water in 5, 10 years? And the other part is the uncertainty that, like, the permits are a significant hurdle. They don't know whether there are going to be very strict regulations for discharge, and exactly the point that you made, that what happens to that product water. It's essentially, if you use thermal processes, you're getting technically a distilled water quality product, but still, as much as I can understand the language, is still is considered it's a produced water. So, and then now they're giving some permits that, yeah, you can use it for some land applications and with very, very, very controlled kind of environment and very, very strict concentrations, the limits. I think that part of it is essentially, that's the part that it's make it very a risky business to kind of investment. I think I have been working with a couple of small companies, investing companies that they are ready to invest here in Texas. They're very interested to invest in produced water. I was in a conference at the DOE conference trying to look into how to recover critical minerals from produced water. The idea was using any type of waste stream. And like there were hundreds of companies, different institutions, and everybody was just saying, we want to go towards produced water because we know that the volumes are large, we know the concentrations are reasonable. And so definitely the motivation is there, but they don't know how to get there. And part of that is that infrastructure, that essentially that situation, it becomes a hub that accepts all the entrepreneurs, all companies, investors, to get the job done is not there. And part of it, I think, is because of that uncertainty that what happens to the product water, what can we do with it? And again, finding out what would be the cost of that water, who is going to offtake it, and who is going to pay for it. Again, some companies I'm working with them that they are happy with surface discharge. They're completely happy with surface discharge into Pecos River. And even that they have to remineralize the water. Essentially, they have to dissolve some more salts into the water before discharge it. But again, still that's not possible because the permits are not there. I've heard that there are some permits that are now being given out. I don't know the details, but soon we should hear back what's going to happen and how this water can be used for not only internal reuse, but also external reuse.
So it sounds as though the uh, pipeline infrastructure has been growing rapidly enough to keep pace with the need, so that is, at least in your part of the country, not particularly the bottleneck. Am I hearing that correctly?
When you say, Ben, when you say bottleneck, do you mean the bottleneck to advancing desalination technology, or the bottleneck to just development in general, just drilling and
I'm
completing?
sorry, to the large scale centralized treatment and so on,
Uh,
regardless of the technology.
yeah, I mean, if you want to bring in 1 million barrels a day into a facility, you're talking about a pipeline that you can almost walk through. So there is a there you know there is there's a next level there of, we've got plenty of pipelines that cross over each other that are carrying 100,000 barrels a day, and then connecting those, manifolding them together, putting them into a larger line that can carry that level of water. That's going to be that'll be part of the evolution. Not that, I mean, there's plenty of industries all around the world that use 48-inch pipelines. It's just, for our industry, there aren't a lot of 48-inch produced water pipelines. So that's the next step, part of the evolution, part of what needs to happen for that centralized treatment at that scale.
What about regulatory policies? Are there constructive discussions with regulators um, in the Permian Basin? Do you think? Uh, I think that it's always true that regulators are by their nature not technical experts in the fields, and that it's easy to have gaps in communication between industry and regulators. Uh, how's that playing out?
Well, first off, the Permian Basin is stretched across 2 states, and one is Texas and one is New Mexico, and those states are very different from one another. So you have Texas, which is a very red state, New Mexico, which is a very blue state, and the environmental policies that govern oil and gas operations in New Mexico are much more restrictive, and in Texas, less so. And one's not better than the other. It establishes a commercial landscape for companies like ours to operate in. And we are finding that we're finding that the different entities in New Mexico, which is a little bit more challenging area to operate for oil and gas, the regulators are coming to the table to learn more about how to reuse water, going back to what's happening today, taking produced water and sending it back downhole on a frac. Because as a quick segue, or a quick rabbit hole here, when we recycle water for fracs, we solve 2 problems. We replace the fresh water that would have otherwise been used for the frac. And then we're also taking water that would have gone into an underground injection well, or a saltwater disposal well. You'll hear SWD a lot, saltwater disposal well. That it's not going down there into that well anymore. It's staying on the surface and remaining part of the oil and gas hydrological cycle, the water management process. So we solve 2 problems when we recycle. And New Mexico, the regulators understand that, and they want more of it, because New Mexico is in the beginning chapters of figuring out induced seismicity, how to work with industry to carve out areas where we shouldn't be injecting in certain horizons, certain geologic horizons. Oklahoma has already gone through that, and they've come out the other side with coming like almost back to baseline seismicity before the saltwater disposal wells. I just saw some good data on this at a conference, New Mexico Oil and Gas Association conference that I just came back from. And Texas has kind of solved it with the seismic activity. There was a baseline, and then it jumped up during a certain period because of injection wells, and the state and the experts in our industry work together to say, hey, we need to carve out this space, and we shouldn't inject here. We shouldn't inject here. We can inject here, but don't go to 5,000 feet. Go to 10,000 feet. And we've worked together with regulators to figure out how do we continue operating and keep this world fueled with oil while protecting the environment. I mean, so we've done that. And in Oklahoma and in Texas, we've established this precedent that we can figure out where are the bad zones. It always leaves lots of lots of green, good zones around for us to work in. And New Mexico is at the very beginning of that. I think that's a good example of how the industry and regulators work together, is working around induced seismicity, which is a real thing. There's people a lot smarter than me that have established that we are, when done irresponsibly, the industry is causing small earthquakes. But we're doing it a lot more responsibly now and working with regulators on that. And I think New Mexico continues to work with companies like ours to understand the problem. And because we are aligned, I mean, despite what people may think of the oil and gas industry from that aren't involved in it, there's a lot of environmentalists in the oil and gas industry. We work and live and raise our kids in these places, and we go to great strides to not to be stewards of the environment. I mean, when we have a spill, we have it cleaned up within hours, soil replaced. I mean, I feel very, I'm very proud of how Select protects the environment. And so we're aligned with regulators. We want to protect the environment, but we don't want regulations that just don't make sense, right? So, for example, there was a bill in New Mexico that proposed that the industry be banned from using fresh water at all. So I understand the intent. The intent is to not use water. It's our most precious resource. To not use it for hydraulic fracturing operations. I get that. But when you put a pipeline in the ground and you want to test it to make sure that all the connections are made properly and there aren't any flaws in that pipeline that you just installed in the ground, you don't want to use salt water for that. You want to use fresh water, because if you have a leak, then you have no disturbance to the environment at all. So it's working with regulators to understand those nuances. Like, yes, we agree with you. We should use produced water for fracs, but there are certain cases where we still need to be able to use fresh water in service to being a steward of the environment. But I think we work pretty well with the regulators. We have a good relationship with them. Yeah, I think I'll stop my comments there. I could go on about this for a while.
Well, I think it leads to a question too of what metrics are appropriate, both for oil and gas companies to apply and for regulators to be looking at. And from both a research perspective, a more purely scientific perspective, and an operational perspective, I'd be curious what you have to say about what each of you have to say about that.
Well, I'm going to stick with water because that's what I know as far as in environmental metrics. I think the metrics that companies at least should track, and that and if I believe companies should track them, then I think regulators should track them as well. I think companies should track how much their freshwater consumption is increasing or decreasing as a ratio of the total water needed for their operations. So I think companies should be striving to reduce freshwater usage as much as possible. And this isn't some outlandish statement. I mean, every one of our customers consistently use 100% produced water for fracs all the time. And the only time that they don't is when we're kind of stranded from an infrastructure standpoint with maybe a step out development, something that they're doing they're exploring a new area geographically, and we don't have the infrastructure out there. So maybe there'll be a little freshwater or brackish water ideally used in those operations. So the use of freshwater, I think recycling, how much water have you put to beneficial reuse or to recycling for your own operations? I think that's a metric that's fair to measure. But I will put one caveat in there. A smaller independent that completes 4 wells a year, they're going to have difficulty reaching the scale to recycle water. You have to have scale to recycle water. And it's not fair to hold an independent producer to the same standards that you're going to hold an Exxon to. So I think there's an independent petroleum association for a reason. The smaller companies deserve consideration for regulations and environmental stewardship metrics like that. That the larger companies kind of, I don't want to say take for granted. They understand the dynamic, but it's a lot easier for them to do. So a company like Exxon, we work with Exxon, and I'm not a spokesperson for them and wouldn't dare speak on their behalf, but I can tell you something that I'm sure they're very proud of, that they recycle a ton of water, and they rarely use fresh water in their operations. And they've put a lot of effort and money into doing so. So, and then I think another metric that should be tracked is spills. You know, when you deal with produced water and you're moving it through pipelines and you're moving it through trucks and you're storing it in ponds, there is naturally going to be equipment failures. People are involved in these processes and people make mistakes, and there are going to be discharges. We capture most of those discharges in containment. So think of like a poly or a polyurea, a plastic containment, and we put that out there under all of our pumps and treatment equipment. So smaller spills, we still avoid them, but when they happen, it's all contained. It never touches the environment. We clean it up, put it in a with the rest of our waste to be disposed of properly. But pipelines fail. It happens. It doesn't happen very often, but good stewards of the environment are going to have fewer spills as a percentage of the total water that they manage, right? Than operators that aren't being as good as stewards of the environment. So, you know, freshwater usage and then spills of salt water is what I would say is something that we should be tracking as an industry, and I think regulators are already keeping an eye on.
Thank you. Dr. Malmali, do you have some thoughts you'd like to add on metrics, perhaps more from the design and research end, or not?
Yeah, meanwhile, I was trying to answer two of the questions in the chat. So, yeah, so I think one of the important points is that, yeah, if you treat the water, particularly regarding desalination, what would be the quality of the final product and how to characterize it? And this is a another very interesting area that this point a lot of certified labs are kind of characterizing the water, but I would say there are a lot of opportunities to improve and also learn more from those. And I would say that there are a lot of constituents in the produced water that after desalination, after treatment, are most probably 99.999% they are gone. They are rejected, removed. So as I said, the quality of the water after desalination is reasonably good. But again, a lot of people are concerned that what if there is something that we didn't take into account. But again, I would say a lot of high resolution mass spectroscopy characterizations and also things that are done in the produced water, like we are working on an Excel file with thousands of methods tested for like 20 samples of water. And they were all showing that all those constituents in the produced water are not non-detectable. So technically all those organics, inorganics, heavy metals, anything you can call it, any chemical that you use for fracking, lubricants, surfactants, they're all removed. So technically that's something that there should be, I think, be an established requirement method that the water can be characterized, and then based on that we can say, okay, this is the product of this water desalination, produced water desalination plant is something clean enough that you can reuse it for surface discharge. So I think that's also under development. A lot of companies are, and also a lot of institutions are investing on that. So I can name at least Texas Produced Water Consortium. We are helping a lot of industry, and also internally, We are now having very, very fancy equipments that we are working on this to get more information about characteristics of the water, what are the elements there. Not only we are looking at targeted analysis, we are looking at non-targeted analysis, which is a lot more complicated. But again, honestly, the results are pretty good. And again, those should form a baseline and a database that we can rely on that. And hopefully we can come up with some metrics that this what can be called a good clean water that could be used for, I don't know, surface discharge applications or for irrigation applications. I think that framework, I think it's under development and hopefully being created soon, because I think that gives the guarantee to anyone who wants to invest in this process is that if I get this quality of the water, then I can sell that water, I can use that water for that specific application. But as long as that doesn't exist, I would say there are a lot of risks on going after such technology. Again, this is my understanding. I have very limited understanding about it, but maybe Aaron can correct me if I'm wrong.
I know of at least 3 different operations in the United States at one point or another that have discharged produced water, desalinated produced water into back into the environment, one method or another, into rivers. And one of the keys to that operation to keep the environment safe is your product that you're creating, the fresh water that you're creating, the desalinated, deionized water that you're creating. You put it into storage, and you test that storage multiple times a day, multiple times a week. You're doing a lot of different tests on it. I know specifically in Arkansas, there was a project many years ago that did this and figured it all out. But that's a key, so that if you have a temporary disruption in your treatment efficiency, you can wait it out with other water where you've exceeded the standards for weeks on end, and then you have a disruption and it goes, and you can catch it, and you just don't discharge that water if it doesn't meet regulatory standards, it doesn't meet the regulations, and it should be a regulated process. We need to make sure that the water we put back out into the environment is suitable to go into the environment and isn't going to disrupt ecosystems or cause problems with whether it's human consumption or growing crops or whatever it may be.
Mm-hmm.
In our part of the country, one of the major public concerns that I'm seeing from the public is radioactivity, radioisotopes in the produced water. Are you seeing that concern, particularly in the Permian? What I have witnessed is once radiation is mentioned, people's anxiety goes way up.
Yeah. Well, it's not a big problem. I'll just start with that comment. Our treatment processes at Select, we have 4 kind of basic goals when we're treating the water for reuse on fracs. So we want to remove as much of the suspended solids as possible. We're not targeting dissolved solids. Excuse me, my phone went off. We're targeting suspended solids. And the reason we want to remove those, it's not for the frac. It's so we can store the water without that water turning and getting a surge in microbiological growth. So we remove the solids. We remove any oil or hydrocarbon products in the water, so that there's not, so that we're not contributing to volatile emissions once we put the water in a pond. So we don't want oil of any kind on the water. We remove iron from the water. That's the one dissolved particle that we're targeting, and that's because the iron can sometimes interfere with completion chemicals and how they act or how they perform. And then finally, and the most important thing, and the thing that we, as a water treatment industry in the oil field, the thing that we're constantly fighting is microbial growth. We are fighting specifically, and there are other bacteria that cause little problems here and there, but the biggest bad actor is sulfate reducing bacteria, which is generally an anaerobic bacteria that if you think of a swamp, Mississippi, Louisiana, that's an anaerobic environment, and we don't want our ponds turning into swamps. Well, that sulfate reducing bacteria can create a dangerous gas called hydrogen sulfide. And the hydrogen sulfide can be created in a pond and create a dangerous environment for the workers, but it also contributes to souring the reservoir itself, potentially, if you don't control that bacteria growth. So our treatment goals, or what we call our KPIs, key performance indicators, are fairly simple. In the water treatment world, it's not a huge hill to climb. The challenge in our industry is that the water changes so much as it comes in because it's coming from different wells and things. So the reason I mention that is because targeting suspended solids and using oxidants to kill bacteria and control bacteria, you aren't going to precipitate the alpha and beta particles that might be stemming from, and I'm getting a little bit out of my depth here, so Dr. Malmali can correct me, but normally it's radium that we see in the water that might give off alpha and beta particles, not gamma. I've never seen gamma particles measured on or gamma. I think I'm saying that right. Gamma radiation. Every now and then we'll see some alpha and beta radiation coming off of precipitated scale in our systems, even though we're not targeting dissolved ions in our treatment. Just because of flow changes in geometry, you will get some scale deposition. And every now and then, I'm talking about mineral scale deposition. And every now and then, it's rare, it's not common, but maybe 5% of the time, something along those lines, you will somehow, the produced water has tapped into some geology that is producing a little bit more of a background a little bit more particles that can or dissolved ions that are radioactive. Very small scale. Alpha and beta particles, for those that aren't aware, it can be stopped by water, by your clothing. So these are very, very, very low level. Even when we do detect it and we do measure our solids to ensure that we aren't exceeding radiation standards, even when it is detected in the very, very rare circumstances, it's very low level, just above background, just above the requirements from an environmental perspective. So for water management, water recycling, I can't speak to drilling and completion operations. I'm sure there's some tubing strings out there that you might have to dispose of in a different way because they may have some radioactivity emanating off of them because of deposited mineral scale. But in the world of managing produced water, select, we don't run into a lot of problems like that. Now, part of that's geology. Like Ben, you're up in the Northeast, and the Marcellus is just, it's more radioactive than formations down here.
Mm-hmm. Mm-hmm.
Yeah, the same as Aaron. I think, especially I would emphasize on the last part that I believe you are from East Coast, Marcellus area. That the water from there is more, it has higher salinity, and it has been reported that it has higher radioactivity. But Permian, I haven't myself seen water samples that they have radioactive materials in it. And even again, we are doing internally and through certified labs a lot of characterizations on the water samples, not hundreds and hundreds of samples, but some samples that we can focus on those very, very carefully. And most of the times, after desalination, as Aaron said, I'm not a geochemist or analytical chemist, so I cannot comment a lot on the gross beta and gross alpha, but those are the two metrics that usually they measure, plus the radium concentration. And usually after desalination, all of them are non-detectable. So even if they are close to the baseline or a little bit concentration existing after desalination, none of them are going to exist. So again, it doesn't mean that it's a solution to everywhere. At the end of the day, I think more research, more knowledge should be shared in between everybody who is involved in academia, industry, exchanging water samples and knowledge and water characterization and sharing this information. But again, with my experience, I haven't seen that in Permian. I cannot comment about Marcellus.
Okay. Well, it's nice to have one less problem to worry about. Um, so I I think that we you've really covered a lot of information on operations and what's currently going on, and I wonder about um, moving to the future even more. I think you've already talked some about the future, but I wonder uh, what more we can say about uh, future direction, uh, and if there's anything more to say about timelines at all.
Hmm. Yeah, we've covered. I think Dr. Malmali and I have kind of talked a little bit about what we see as timelines, and Dr. Malmali may be, but I am not a fortune teller, and I'm just speaking from one small perspective in the Permian Basin. I think that the industry is on a inevitable path to desalination. There's a lot of money being invested in it. Every Select and every one of our competitors is investing in trying to figure this out, and it stems from some of the things we talked about at the top of this of our session here. There is decreasing injection capacity just because we've got seismic areas, we've reduced our footprint of where we can inject, but there's only a finite amount of pore space out there, and we continue to produce water. This isn't a problem for tomorrow, but down the line we do have to figure out other ways of managing produced water and turning it into a viable asset for the local community and for the hydrological cycle that we all depend on. So that's the future. I mean, you are not going to get away from saltwater disposal wells. Your recycling is going to be the I don't want to call it easy, but the easiest way of protecting the environment and reducing freshwater consumption and reducing underground injection. And Select's invested hundreds of millions of dollars on that in infrastructure to allow for recycling just over the last couple of years. So recycling. I think there's just going to be, in the near term, in the next 2 to 3 years, regulators and the industry is going to work together to establish rules and policies that allow us to recycle as much water as possible. And again, by recycle, I mean using our produced water for fracs for the most part. And then a little bit farther out on the horizon is, I think, desal, and it's inevitable. We'll figure it out eventually. Academia will give us the technical solutions, and we'll all figure out how to get it out there and make it commercial and do it the right way where we're being good stewards of the environment.
Mhm.
Yeah, I agree with Aaron, and I think I know that some companies have started putting some small plants, 10,000 barrels, 20,000 barrels per day, to start this, and which is good. Again, to take off, you need some basic data to be generated to understand what we are dealing with, what problems could be caused down the road, and then based on that, further scaling up. So hopefully in the next 1 or 2 years, those plants are up running and we get some more information, and then probably in a couple of years, 4 or 5 years, I think hopefully we are going to see a more interest coming from industry to do more desalination, less discharge. And I think two major factors are going to be involved. One is the cost of water. Second thing is how the AI is going to influence the produced water environment, because I believe, again, I'm not an expert in this area. I would love to learn more about it. I'm reading articles, not scientific, but news articles, like a couple of years ago, a lot of these data centers were rushing to get to Texas because of water for their cooling system. And now the new design generation of the data centers, it's not that water intensive anymore. It's more the energy intensity becoming a problem, which again, grid being super limited, what makes Texas interesting for them is the natural gas and essentially generating energy and electricity. So is that going to influence whether desalination is going to prioritize or not over data centers? That's one of the things that I think it's going to be an interesting subject to watch. Again, 2 years ago, produced water it's a significant asset for data centers for cooling. But now that they are more sustainable in terms of their water consumption, is the essentially competition to get the energy for desalination, because that's also a lot of challenge for anyone who wants to do desalination, where the energy source is coming, who is going to supply the electricity.
But Ben, if it's okay with you, there's a couple of questions here that I wanted people
Yes.
to the time to ask the question. So I thought maybe we could just, we don't have a ton of
Yes,
time.
thank you.
Maybe just hit those quickly. So what new types of problems, if any, are E&P customers bringing you to solve? The one that popped into my mind the most is very high completion activity intensity geographically. So completing 12 or 16 wells all in one operation over the course of however long it might take, 4 weeks, 8 weeks. That requires a ton of water. And that is a logistical challenge. And that's something that Select is, I don't want to sound too sales pitchy here, but that's something that Select has been called to answer. And we've done a pretty good job at bringing, 400,000 barrels a day to one location for 30 days. And that's a lot of water. And it takes a vast network to bring that much water to bear in one geographical area. And I think that what's driving that is just better economics, better returns on the wells. The return on invested capital on the wells themselves, they find is better because, of course, economies of scale. You can lower those costs, and water has to come along with that. We have to be able to provide the water, and then we have to give them the means of taking the water away when they open these 16 wells up. Maybe not exactly at the same time, but over the course of a couple of weeks. Well, before I move on from that, Dr. Malmali, did you want to comment on that question?
That's your question.
Are prices expected to rise to dispose of produced water? I'm not a economist, but just I think most of the folks on this call have probably taken an economics class at some point or will, and supply and demand dynamics probably dictate that produced water disposal via disposal wells will go up. You've got an increasing amount of produced water and a finite amount of disposal, and for regulatory reasons, in New Mexico there have been significant chunks of disposal wells shut down by the state for various reasons. Some of them have nothing to do with the environment. Those wells were competitive with an oil water flood operation in one case, but it seems like the disposal capacity is not expanding with the produced water increase, and just supply demand dynamics dictate that I think prices will go up over time. And then let's see.
Yeah.
And then the beneficial reuse. We are investing significant money and time into beneficial reuse, and we've talked about that quite a bit here today. When can we see those go commercial to a commercial scale? The honest answer is I don't know. There's a regulatory landscape that needs to develop a little bit more for us to understand as a company how to mitigate our investment risks before we start diving into, we're $1.5 billion market cap company. There's some risks that we need to mitigate financially before we can really dive into that space, and we're working on it.
Yes, thank you. I'm glad that you uh, responded to those questions. Uh, the I think in our closing minutes, one of the canned questions, what what's the biggest misconception about produced water management, particularly in the Permian? Uh, do you have any thoughts
Yeah,
on that?
for me anyway, the biggest misconception is from the public that we are somehow bad actors. And I know that that's usually a loud minority, but I think if I were going to just speak to a random sampling of people in the world, people in the Permian Basin, or maybe even outside the Permian Basin that are just environmental activists, I would just tell them that we're not just suits in Wall Street. Like the people that are really doing things out there every day, we raise our children in these areas. We drink the water. We go hunting and fishing. We also live in this desert where water is precious, and the people that are really turning valves and running operations, treating water out there, we are environmentalists. I mean, we want to protect the environment. We want to go to great lengths to make sure that our operations aren't negatively impacting the environment around us. As in any sector, on any topic involving humans, there are going to be bad actors, and those get the most press. But the good news is for the oil and gas industry, you know, greater than 99%, greater than 99% of the people out there that are in charge of managing produced water are doing the right thing every day. And I can attest to that because I manage a big team of them, and we go to great detail to do the right thing when no one is, go to great length to do the right thing when no one is looking.
Yes, thank you. I think actually that this topic could be a podcast of its own, because how it is that we have really failed pretty miserably in terms of our image. I personally have actually had people pull away from me, even wipe their hand on their shirt after shaking my hand when they find out I'm a petroleum engineer. Um,
And
and
then they go jump in their Denali and drive home.
quite. Um, so I think that that's um, a thing that all of us in the profession should be thinking about is how do we help people to see us as people working conscientiously uh, to provide the energy that they need. Um, and personally, I'm going to interject a personal thought that I think at least most Americans take energy for granted to the point that they fail to see energy as a survival issue, only as a how much do they pay at the pump for gasoline. And I think that's a part of it. Um, but let me try to close on your thoughts um, in terms of maybe advice to young engineers uh, that may be entering the water management field. What are the opportunities and challenges you might give a piece of advice to?
Why don't you take that one, Dr. Malmali? I've probably been talking too much here over the last few minutes.
Uh, I think in terms of what are opportunities that are existing, is that the question in the produced
Well,
water?
uh, however you want to take the question.
Yeah.
What can you tell a young person um,
I think
to guide them?
I think especially if you are interested in water, you're interested in fossil energy, oil and gas. I think again, water is a very, very, very interesting topic. It's especially produced water, how to handle produced water, and how, again, the management part of it is fantastic. It's very interesting. There's a lot of work being done, but if you want to make a career around water in this area, I think trying to invest learning how this essentially water management works and trying to learn about desalination technologies and doing research or being part of the research and development efforts in the companies, academia, that they work on desalination, they work on resource recovery, they work on essentially valorizing produced water. I guess, and I think Aaron at some point highlighted that it's going to be the future. And if you want to guarantee a good career for yourself, and if you're interested in water, uh, energy nexus, that's the right, at this point, this time, I think it's a perfect time to jump into on this opportunity and try to equip yourself with the skills that are needed to get into this type of career and hopefully be successful for the next 30, 40 years of life.
And
Thank
I would
you. I
say
think beautifully said.
very well
Yes.
said. I would just say for the young engineers, young students out there, especially, that I would imagine if they're listening to this, then they are most likely on a technical track, going after an engineering degree or something very technical. That don't forget that whether you're an academic, whether you're trying to invent technology, or whether you're out solving problems in the field, operations, whatever it is that you plan to do with the knowledge you're gaining, you have to communicate. You have to learn how to communicate effectively, whatever your ideas are. So don't, as important as it is, I mean, it's fundamental to what you're doing. You're learning technical things. You're learning, you're learning physics and chemistry and all those things. That's when you come into the industry, that's a given. We expect you to be technically sound. What separates engineers is the ability to connect with people and communicate their ideas. So as you look to sharpen your saw in the different areas of life, in academia, don't forget to pick up a book every now and then by Dale Carnegie or Stephen Covey or those guys that talk about how to communicate effectively and connect with people. Because whether you like it or not, coming from an engineer that's an introvert and loves to be in the quiet by myself, to accomplish anything in this world, you have to work with others. So invest in learning how to do that.
Excellent. I really want to thank both of you. I think this has been extremely informative, and I know I learned a lot. So I'm hoping that the audience feels the same way. And just tremendous thanks to both of you.
Yeah, thanks for having us.
Yeah, thanks. I appreciate it. I enjoyed it. Dr. Malmali, I hope I'll run into you at some point out there.
Yeah, same here. Good to meet you virtually.